What is the world's biggest problem? Wars? Poverty? No. There's a fundamental issue underlying all of them: energy. Fossil fuels are choking our planet, and existing nuclear energy carries inherent risks. But what if I told you there was an energy source that is completely clean, virtually limitless, and inherently safe? Today, we dive into science's greatest promise, the project to bring the sun to Earth: fusion energy. What is fusion? Fusing the atoms. Fusion is the very same reaction that has powered the sun for 4.5 billion years. It means combining atoms rather than splitting them. The core reaction: you take two light atoms, typically deuterium from water and tritium produced from lithium, and smash them together at such incredible speeds that they fuse to form a heavier element: helium. During this fusion, a tiny bit of mass is converted into pure energy. This is the most powerful demonstration of Einstein's famous formula, E equals mc squared. A single gram of fuel can produce energy equivalent to thousands of tons of coal. Fusion versus fission. So, how is this different from existing nuclear power plants? Current plants use fission. Fission produces energy by splitting heavy atoms like uranium. Fuel. Fission uses radioactive fuel. Fusion uses clean fuel, deuterium, sourced abundantly from seawater. Waste. Fission leaves behind long-lived, hazardous radioactive waste. Fusion primarily produces short-lived radioactive waste, and its main byproduct is harmless helium gas. Safety. Most importantly, there is no risk of a runaway chain reaction in a fusion reactor. In the event of any malfunction or loss of control, the reaction stops instantly. A meltdown scenario is technically impossible. The big challenge: containing the sun. Fusion sounds amazing, so why aren't we using it yet? Because for the reaction to occur, we need to create an environment 10 times hotter than the core of the sun, around 150 million degrees Celsius. Plasma. At this heat, matter is not a solid, liquid, or gas. It's a fourth state called plasma. If this superhot plasma touches the reactor walls, the reactor instantly vaporizes, and the plasma instantly cools down. The solution: we use massive superconducting magnets to suspend the plasma in midair. These magnets confine the plasma within a donut-shaped magnetic cage called a tokamak, or the more complex stellarator. The challenge here is achieving net energy from the plasma, more energy out than energy put in. The big project: ITER, the world's most expensive science project. Fusion is not a task a single nation can handle. That's why ITER, International Thermonuclear Experimental Reactor, is being built in southern France through the collaboration of 7 different countries: the EU, China, India, Japan, Korea, Russia, and the US. The goal: ITER's purpose is not to be an electricity plant. It's a giant experiment designed to prove the principle of commercially viable fusion by producing 500 megawatts of thermal power from just 50 megawatts of input, achieving Q equals 10. Recent breakthroughs. The tipping points. In recent years, there has been major excitement. NIF, USA. The National Ignition Facility in the US achieved ignition for the first time in history in 2022. This means the reaction produced more energy than the laser energy put in to start it. It was a massive scientific victory. JET, UK. Europe's Joint European Torus broke its own energy production record last year by sustaining fusion for 5 seconds. Private sector. Private companies like Helion and Commonwealth Fusion Systems are receiving billions in investment to make fusion faster and commercially viable. This signals that the race to commercialization is on. Conclusion: hope in the future. Fusion energy is not a luxury for our planet. It is a necessity. ITER is expected to be fully operational around 2035, with commercial plants potentially appearing by the 2050s. When that day arrives, energy crises, air pollution, and the fear of nuclear waste will cease to exist. We are close to unlocking the sun's secret and creating our own clean power. What are your thoughts on this technology? Let me know in the comments below. If you like this video, smash that like button and subscribe for more on the technologies of the future. See you next time.